What you doing?
Daydreaming.
What does a Heinemann daydream about?
Square wheels. Like, what if you put square wheels on a truck?
I would imagine it would give you the roughest possible ride. It would be the clunkiest imaginable ride.
Well, it would in the start, but if you went fast enough, it'd eventually smooth out, wouldn't it?
You're wondering how fast you have to drive with square wheels in order to get a smooth ride.
Yeah.
That's great. I think we should put it to the test.
Let's do it.
I'm ready.
All right, here we go. The moment of truth. Square wheels, smooth ride. All four wheels flat. In 3, 2, 1, go.
They're off to a bumpy start.
Hey, that's going right out.
But as Jamie accelerates, the ride seems to get smoother. At least until it suddenly stops altogether. But even in that 15-second window, the wheels did get up enough speed to spin corner to corner. However, do the sensors confirm that it was smooth?
All right, Scott, what do you got for us?
Well, you can definitely see some trends here. As the speed goes up, the vertical acceleration and suspension is definitely going down. If I go to the steering column, you see the same trend. As the speed goes up, vibrational energy definitely goes down.
Well, the data is pretty compelling, and it actually seems to match what Jamie and I felt in the truck, which is that before it destroyed itself, we actually felt the ride smoothing out. There might just be something to this, so we're going to keep on testing it.
Now this is the orientation we had our wheels in for our most recent ride, and a bumpy ride it was. But this is not the only orientation we need to have our four wheels. We could mount two of our wheels at a 45-degree offset to the other two, thus doubling the frequency with which one of the points of the squares hits the ground for every rotation. Or we could offset each wheel by 22.5 degrees for every rotation, thus quadrupling the frequency with which one of the points hits the ground. Which one of these is going to give us the smoothest ride? I haven't the slightest idea. That's why we're about to test this in small scale.
Our small scale test showed that the best configuration was to have two opposing corners with their points down, the opposite two corners with their flats down. That balances things out the best, and so that's what we're going to do full scale.
Square wheels, smooth ride, 45-degree diamond formation in 3, 2, 1, go! Oh! Whoa! Yeah! Come on, baby! Oh, that's not bad! Faster!
To begin with, the offset wheels are smoother.
Yeah! Holy wow!
And as lead-footed Heinemann gets the truck up to speed,
Wow, dude, this is not bad! 18 miles per hour! Keep going! Wow, come on, faster!
it continues to improve. That is, until the wheels can take it no more.
Wow! Wow!
Let's face it, there's a very good reason they don't put square wheels on cars.
Come on, faster!
But you know, that started me thinking. Maybe there are circumstances where square wheels would be the best thing. Like, what if you had a really steep hill covered with loose dirt that you wanted to climb? Round wheel hill climbing control test in 3, 2, 1.
Think that's as high as you can go?
I think so.
That's pretty darn high.
Yeah.
Halfway up the hill, and the round wheels can't get a grip on the loose earth. So the benchmark to beat has been set.
This is Square Wheels, the final hill climb. In 3, 2, 1, go! Oh yeah, come on. Yes, 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 go! Bring that ball! Bring it! Yes, no, come on! Ah!
Just like the round wheels, the spinning square wheels can't get purchase on the loose ground.
So how do you want to call this? Do square wheels give you a smooth ride?
Well, as ridiculous as it may seem, I think we gotta call that one plausible.
What about hill climbing?
That one, not so much. The square wheels didn't provide any kind of significant advantage over the round wheels.
Yeah, well, what are you gonna do?
You want to drive back to the shop?
Now let's walk. It's more comfortable.
Okay.